Hello students, welcome back to the 8th video of this playlist. In this video, we will be solving question number 8 from the recent past paper of Pure Mathematics 2, which is the May 2024 P2 paper. So let's get started with question number 8. Okay, so at first part 1A. In part 1A, the question says in an arithmetic series, the first term is A and the common difference is D. Show that S of n is basically sum of the first n terms of the arithmetic series equals to n over 2 times twice of A plus n minus 1 times D. That means we have to prove this formula of the sum of the first n terms of an arithmetic series. Okay, so for part 1A, to prove this, at first consider the terms of the arithmetic series. Let's consider the sum of n terms. Okay, S of n. So S of n equals to what? The first term is A, the second term is A plus n minus 1 times D. The nth term of an arithmetic series, it is basically A plus n minus 1 times D, right? Okay, so the second term, that would be A plus D, right? So it keeps going like this, and then the term just before the last term, it would be A plus n minus, the last term is n minus 1, so the term just before the last term, it is n minus 2 times D. Okay, and the last term of the series, it is A plus n minus 1 times D. Okay, this is the sum of n terms. Now what we will do is that we will consider the same summation but just opposite way. So opposite way, it would be A plus n minus 1 times D, A plus n minus 1 times D. The second term would be, in this case, A plus n minus 2 n minus 2 times D. Okay, so it keeps going like this. So in this sequence, the last term before the term just before the last term, it would be A plus D. This is basically this one. Okay, and at last the last term would be the first term of the first summation. Okay, now add both of the terms. Let's say this is the first term and this is basically the second term. Okay, so now add them up. First term plus the second term, that would give you S of n plus S of n. This is basically twice of S of n. This is equals to, look, A plus, if you consider A plus the first term of the first equation and the first term of the second equation, if you add them up, you will get A plus nd minus nd. Okay, so twice of A plus, if you take nd minus d, not nd, so if you take d common, you will get n minus 1 times d. Same goes, this is for the first term of the both equation. Now consider the second term of both the equation. If you consider a plus d, it would be a plus d plus a plus nd minus 2d. So 2a plus, okay, d minus 2d. So this is just negative d. So nd minus d, we can take d common, so that would be n minus 1 times d. So like as that, if you add their respective corresponding terms of each of the equation, you will see that they are giving 2a plus n minus 1 times d. Okay, so we know that in S of n terms there are total of n number of terms, so that means that would be n number of twice of a plus n minus 1 times d. Okay, n number of twice of a plus n minus 1 times d. Therefore S of n, sum of first n terms of an arithmetic series, it is n over 2 times 2a plus n minus 1 times d. That's it. That's showed. Okay, these are just rough works. You don't need to show them. I just showed you here to understand, to make you understand about the approach. And that's what part A of 1 has asked for. Fine. Okay, next is part B of 1. Okay, here the question is asking, hence find 900 plus 892 plus 884 plus ... plus 500. So we need to find out the sum of this arithmetic series, and it says hence. That means we have to use this formula for summation. So to use this formula for summation, we need to have the value for n, the number of terms in the series, and then we need to know the first term. So first term here, it is basically 900, and we need to know the common difference. Okay, so let's figure out these values. Okay, so the first term, it's basically 900. The common difference is 892 minus 900. That would give you negative of 8. We got the value for a, we got the value for d. Now we have to find out the value for n. Okay, so the last term of the given series, it is 500. So nth term of the arithmetic series, it is an equals to 500. So nth term, it is basically a plus n minus 1 times d. What's d there? D is basically negative 8. This is equals to 500. Okay, so take 900 to the right side and multiply out the bracket. So negative 8n plus 8 equals to negative 400. So the value for n would be negative 400, negative 8. So negative 408 over negative 408 over negative 8. So that would give you 51. So that means there are 51 terms in this series from 900 to 500. So sum of the first 51 terms of the series, it is n over 2 times twice of a. The value for a, it is basically 900, the first term. Twice of a plus n minus 1. 51 minus 1 is 50 times d. 50 times negative 8. Okay, now just find out this summation. You will get the answer. Okay, so 2 times 900, it is basically 1800. 1800 minus 50 times 8 is, it is 400. So you will get 1400 times 51 over 2. That is basically 35,700. This is the sum of the given arithmetic series. Fine. Okay, next is part 2. In part 2, the question says, given that the first 3 terms of a geometric series are k plus 4, k minus 2, 11 minus k. Okay, where k is a constant. So part A is asking to show that 2k squared negative 11k minus 40 equals to 0. Okay, so since the given series, it's basically a geometric series, so definitely it has a common ratio, isn't it? So for common ratio, that means the ratio of the second term, and the first term will be equal to the ratio of the third and the second term. Okay, so second term is k minus 2. Okay, for part 2a, the second term is k minus 2 over the first term, k minus 2 over k plus 4. K plus 4, this is equals the third term, 11 minus k. 11 minus k over the second term, which is k minus 2. Okay, so it is because the given series it's geometric, so it has a common ratio. Now cross multiply. So if you do cross multiplication, 11 minus k times k plus 4, that would be equals to k minus 2 times k minus 2, which is k minus 2 whole squared. Okay, now multiply. You will get 11k plus 4 times 11, it is 44, and then negative k times k, it is negative k squared, and then negative k times 4, which is negative 4k. Now expand the quadratic expression, which is k squared negative 4k plus 4, that is k a square minus 2ab plus b squared, just the formula. Okay, so take all the terms to the right side, so you get negative k squared there. So if you take it to the right, so k squared plus k squared, it will become twice of k squared. Next you got 4k plus 11k, which is 15k. So negative 4k negative 15k, it is basically negative 19k. Then you got plus 4, and here it is plus 44 on the left side. So if you take it to the right side, it will become negative 44. So 4 minus 44, it is negative 40 equals to 0. Okay, now let's solve this quadratic equation. Is it possible to do middle term? 40 times 2, it is 80. 19. Okay, to get 80, let's apply quadratic formula. This is minus b plus minus square root of b squared minus 4ac. B squared is 19 square minus 4 times 2 times negative 40. So that would give you 681. Okay, I think they didn't ask you to solve the equation, right? Okay, we have done more than that. 2k square negative 11k negative 40. Okay, but we got here 19k instead. Okay, the problem is here it is basically negative 4k. It was supposed to be negative 4k. Negative k times positive 4, it is basically negative 4k. Okay, so we have to stop it there. They just asked to show this quadratic equation. Okay, so 11k, we got 11k there, negative 4k. So 11 minus 4 is 7k. If you take it to the right side, negative 4k, negative 7k, it is basically negative 11k. And that's what part 2a exactly has asked for. 2k squared, negative 11k, negative 40. Fine. Okay, next is part B. In part B, the question says, given also that this series is convergent. So part B is asking to find the value of sum up to infinity. Okay, convergent series. Okay, when a series is convergent, basically a series is convergent when the value for the common ratio, when the modulus of common ratio, it is less than 1. Okay, when the value for the modulus is less than 1, then we say it as a convergent equation, convergent series. Okay, so in that case we have to figure out the common ratio of this sequence of this series at first. Okay, so to find out the common ratio, we need to figure out the value for k, because k is unknown in the series. Okay, so we got the equation, we got a quadratic equation in terms of k. So let's solve this quadratic equation. Okay, so we can use middle term factorization. 40 times 2, it is 80. So for 80, we have 18 times, not 80, wait, 80. 40 times 2 it is 80, so 8 times 10 it is 80. 12. Okay, let's use a quadratic formula, that's better. So k equals to minus b plus minus square root of b square minus 4ac. So b squared is 11 squared, negative 11 squared is 121 minus 4 times 2 times negative 40. Okay, so that would give you 441. So square root of 441. Okay, over twice of a, which is 4. So either the value for k is square root of 441, it is 21. So 11 plus minus 21 over 2. Okay, the middle term was supposed to be 21 and 10. Okay, that's fine. We have figured it out using quadratic formula. No problem. Both will work. So either k equals to 11 plus 21. 11 plus 21 is 32. And 32 over 4, it is basically 8. Or k equals to 11 minus 21, which is negative 10 over 4, which is negative. Okay, 11 minus 21, it is negative 10 over 4, which is negative 5 over 2. Okay, now we have to consider which ratio, which value of k will give the common ratio less than 1. That would be the accepted common ratio. Okay, so consider if k equals to 8, then the first term is basically k plus 4. K plus 4, it is equals to 12, and the second term is k minus 2, which is 6. If I'm not wrong, k plus 4 and k minus 2. K plus 4, k minus 2. Okay, and we don't need the third term, so consider the common ratio. So r, so common ratio, it is equals to second term, it is 6 over 12, which is half. Okay, and if k equals to the other value we got, it is negative 5 over 2, then k plus 4, it is negative 2.5 plus 4, it is basically 1.5, that is 3 over 2, and the second term, it is k minus 2, which is negative 5 over 2, negative 2, which is negative 4.5, that is negative 9 over 2. Okay, now if you consider the value for r, common ratio, that would be negative 9 over 2 over 3 over 2, so it gives negative 9 over 2 over 3 over 2, it gives negative 3. So negative 3, it is less than negative 1, and we know that for convergent series, the value for r should be less, the value for modulus r should be less than 1. So half is the common ratio. Now find out the sum of the up to infinity. So sum up to infinity, the formula for sum up to infinity, it is a over 1 minus r. So a, the first term, when r equals to, when k equals to 8, we got the first term, that is 12. So 12 over 1 minus half. 1 minus r is basically half. Okay, so 12 over half, which is 24. So sum up to infinity, we found it is basically 24, and that's what part 2b has asked to find. That's it, and that's the end of the question number 8. Fine.